Okay, so today we're going to look at 2-3 linear functions. This is going to be a lot of review from Algebra 1 and Algebra 2. There is going to be one form that we're going to look at that is slightly different than one you've seen before. Okay, so the first thing with any linear function or equation is we need to know our slope. Remember, our equation or our variable for slope is m, and we look at either rise over run, or we look at our equation y2 minus y1 over x2 minus x1. Alright, so our first example, we're looking at finding the slope of a line. For this first one, I'm going to label our points x1, y1, x2, y2. Now, if we want to solve for our slope, we're going to plug into our formula. So we have 4 minus negative 1 over negative 2 minus negative 3. Remember, two negatives make a positive, so this is actually 4 plus 1 and negative 2 plus 3. So 4 plus 1 is 5, and negative 2 plus 3 is 1. And we can simplify 5 over 1 to be a slope of 5. Okay, so looking at our second example, I'm going to label our points again, x1, y1, and x2, y2. So our slope, m, equals negative 2 minus 4 over 2 minus negative 3. Two negatives make a positive, so I'm going to change that to a plus sign. So negative 2 minus 4 is negative 6. And 2 plus 3 is 5. So our slope reduced is negative 6/5. Remember, if you can reduce the fraction, you need to make sure to reduce it. Okay, our next form of a line is going to be point-slope form. Remember, this is our form y minus y1 equals m times the quantity x minus x1 with slope m. And through the point x1, y1. Okay, remember we're going to leave y and x the way it is. So our example for point-slope form, we want to write an equation in point-slope form for the line with slope 4. So right there, that tells us that m equals 4. And passes through the point negative 1, 3. So I'm going to go ahead and label this point as our x1, y1. So for point-slope form, we're going to have y minus our y1, which is 3, which equals our slope 4, times the quantity x minus x1, which is negative 1. Okay, we can simplify this to be y minus 3 equals 4 times the quantity x plus 1, because two negatives make a positive. So for this first part, we're just looking for our point-slope form, so that would be our solution. The second part of this problem, it asks us to go ahead and solve the equation for y. So to get y by itself, we're going to want to distribute to get rid of our parentheses. So now we have y minus 3 equals 4x plus 4. And then to get y completely by itself, we're going to add 3 to both sides. So y equals 4x plus 7. For those of you that don't remember, that form of a line would be our slope-intercept form. Which is y equals mx plus b. Okay. All right. Second example, write an equation in point-slope form for the line passing through the points 4, negative 3, and negative 2, 6. Sorry about my dog. And then solve the equation for y. So on this problem, we're not given our slope, so we need to find our slope. So x1, y1, and x2, y2, labeling our points. So first step always is to find our slope. So we have m equals. So we're going to subtract our y's. So 6 minus negative 3. Okay, 2 negatives. Go ahead and make that a positive. And we're looking over negative 2 minus 4. So 6 plus 3 is 9. And negative 2 minus 4 is negative 6. We can reduce this fraction by 3. So this reduces to be negative 3 halves. Okay. So now you have options for our point slope form. It doesn't matter which point you use. I will accept both of them, and so will your homework. So if we go ahead and just use this first point for negative 3, since it's already labeled as our x1, y1, we would have y minus negative 3, which equals our slope, negative 3 halves, times the quantity x minus 4. Now if we want to simplify that, remember 2 negatives make a positive. So our point slope form would be y plus 3 equals negative 3 halves times the quantity of x minus 4. Okay, so there is our first solution. Okay, and then lastly, it wants us to solve for y, which really is asking us to put it into slope-intercept form. And I apologize if you can hear my dog chewing on her bone. Alright, so if we want to solve for y, we're going to start with distributing. So we have y plus 3 equals negative 3 halves x. Okay, negative 3 times negative 4 is a positive 12 over 2. I'm going to go ahead and write that. And remember, 12 divided by 2, we can simplify that to just be 6. Okay. And then lastly, to get y by itself, we're going to subtract 3 from both sides. So we end up getting y equals negative 3 halves x plus 6 minus 3 is 3. Okay. All right. Looking at our second page here. Oops. Scroll down. So we just talked about this, the slope-intercept form of the equation of a line. Okay, that's going to allow us to graph. So we have y equals mx plus b. Okay, remember m is our slope, and b is our y-intercept. Okay, or the point where the line crosses the y-axis. So if we look at this graph the linear function f of x equals negative 3 halves x plus 2, remember f of x is the same thing as y. Okay, so we can rewrite this, y equals negative 3 halves x plus 2. Okay, we know from that that our slope is whatever's in front of x, so negative 3 halves, and our y-intercept is 2. Okay, so I'm going to go over here, and I'm going to graph this. So we're going to go up 2 on our y-axis and put our first point. Then we're going to go down 3 and to the right 2. Or we could go up 3 and to the left 2. And then connect those points. And we have our straight line. Alright, our other type of linear equations are when we look at horizontal and vertical lines. Okay, some of you may remember our anagram Hoy-Bucks. So remember we have, it's H-O-Y. That tells us we have a horizontal line. With 0 slope. And a y-intercept. Okay. Also with that, it tells us that y equals a number equation. Okay. And so there's our Hoy. Then we have our Vux, V-U-X. which is our vertical line, with an undefined slope, and here we're going to have an x-intercept, or x equals a number equation. Okay. So what's nice about this is we just split this up exactly how the next examples are. So we have y equals -4, which tells us that we have a horizontal line. Okay, so remember when we're graphing, we need 2 points. So on your homework, you're going to go down 4 onto your y-axis, and then you just need to pick a point on either direction to the left or to the right, so that way you can get that solid straight line. Okay, when you're doing a quiz or a test, I don't care if you actually draw that second point, but you will need that second point for your homework. All right, so then if we look at our equation, graph x equals 2, since it's x equals, we know we have a vertical line. So we can go over 2 on our x-axis, put our point, and then again go anywhere above or below for your second point, and connect them for your line. Okay. Easiest way to remember this, if it's y equals, it goes through the y-axis. If it's x equals, it goes through the x-axis. All right, page 3. So normally our third method of a linear equation is standard form, where we had ax plus by equals c. I'm going to write that up here. Ax plus by equals c, and with that we had, let's see here, with no fractions. Okay, we always had integers or whole numbers within that for our a, b, and our c. And we're going to slightly change that for general form of an equation of a line, and that becomes ax plus by plus c equals 0. Where a, b, and c are integers. So it's very similar to what we've already learned in previous courses. It just is going to always make our equation equal to 0. Okay, that's going to be our main difference. Okay, so the first thing we're going to do with that is if we have an expression or an equation in general form, we want to use it to find the slope and the y-intercept of the line. Remember, if we want to find the slope and the y-intercept, we want to go into slope-intercept form. Which is y equals mx plus b. Okay, so we want to get, y by itself. So you have two options. You could either move this 3x and the -4 to the right-hand side, or what's easier and less work is if we just subtract this 2y to the right. So we have 3x minus 4 equals -2y. Then to get y by itself, we're going to divide by -2 from all three terms. Okay, so those cancel. So we have -3/2 x, and then -4 divided by -2 is a +2. And if you want, you can go ahead and move that equals y to the front. Okay, so now we can easily tell that our slope is -3/2, and our y-intercept is 2. One thing to remember when you're writing the slope of your line, don't put an x with it. Remember, slope is just a number to represent this, how steep or how narrow your graph is going to be drawn. Okay, so that's one method to use the general form of an equation. The method we use more often, which we looked at when we did standard form in previous classes, is using it to find the intercepts of our graphs. Okay, so I went ahead and added in there our steps for finding our intercepts. Remember, if you're finding your x and y intercepts, you always plug in 0 for the alternative variable. Okay, so when we're finding our x-intercepts, we let y equal 0. So in this equation, 4x minus 3y minus 6 equals 0. We're going to have 4x minus 3 times 0 minus 6 equals 0. Well, what's nice is this 3 times 0 automatically cancels. So we can add the 6 to the other side. 4x equals 6. Divide both sides by 4. So our x-intercept is 3/2. Or since we're going to be graphing, we could say our x-intercept is 1.5. Okay. I don't personally care if you write it as a fraction or a decimal. Make sure when you're doing your homework, though, you are reading the directions underneath to determine how it wants it written. All right, so our x-intercept is 1.5, so we're going to go to the x-axis and put our first point halfway between 1 and 2. Okay. Okay, our y-intercept now, we're going to let x equal 0. So we have 4 times 0 minus 3y minus 6 equals 0. 4 times 0 cancels. And we can add our 6 to the other side, so that way our y term is by itself. So negative 3y equals 6. Divide both sides by negative 3, and we get our y-intercept to equal negative 2. So if we're graphing that, we're going to go down 2 on our y-axis, put our point, and then we can connect our dots with our straight line. Okay. A lot of times finding our x-intercepts is a lot faster than having to actually get into slope-intercept form, especially since we're letting our y equal 0 and x equal 0, and it eliminates those terms. All right. So now let's apply it all to this problem. So the amount of carbon dioxide in the atmosphere, measured in parts per million, has been increasing as a result of the burning of oil and coal. The buildup of gases and particles traps heat and raises the planet's temperature. The bar graph below gives the average atmospheric concentration of carbon dioxide and the average global temperature for 6 selected years. The data are displayed as a set of 6 points in a rectangular coordinate system below to the right. Okay, so what we are looking at is this graph over here, this scatter plot. Okay, so it says for part A, shown on the scatter plot is a line that passes through or near 6 points. Write the slope-intercept form of this equation using function notation. So we know that if we're wanting to write the equation of a line, the first thing we need to always find is our slope. Okay, and we're going to use the 2 points that it has highlighted for us on the graph, the 326 and 57.06. and 385, 57.99. Okay, so I'm going to let's see, this is going to be x1, y1, and x2, y2. And if we plug into our slope formula, we have m equals, so let's hear y2, 57.99 minus 57.06, all divided by 385 minus 326. Okay, so if we subtract our numerator, 57.99 minus 57.06, we get 0.93, and then 385 minus 326 is 59. We don't like decimals inside of our fraction, so I'm going to go ahead and divide this So 0.93 divided by 59. And I'm going to round this. Let's see here. We have 0.016. Okay, so there's our slope. So now we want to write this in slope-intercept form, but I'm going to use point-slope form to get there. So we have y minus, and I'm just going to use that first point. So 57.06, which equals our slope, 0.016, times the quantity x minus 326. And now we just want to get y by itself. So we're going to start off by distributing our slope inside of our parentheses. So y minus 57.06 equals 0.016x, and then 0.016 times 326 is going to give us a negative 5.216. And then add the 57.06 to the right-hand side of your equation. So we have y equals 0.016x plus 51.844. Okay, so we are almost done. It tells us to write it in function notation, which changes it up a little bit. Remember, function notation is f of x, so we're just going to change this y to be f of x and then rewrite our equation. 0.016x plus 51.844. You are going to have problems like this on your homework. Make sure you read what it wants it rounded to, if it's the 100th or the 1000th place. All right, then part B. The pre-industrial concentration of atmospheric carbon dioxide was 280 parts per million. The United Nations Intergovernmental Panel on Climate Change predicts that global temperatures will rise between 2 degrees and 5 degrees if carbon dioxide concentration doubles from the pre-industrial level. Compared to the average global temperature of 57.99 degrees for 2009, how well does this function from Part A model this prediction? So, if we look up here, we can see that our x value represents the average carbon, our average carbon dioxide concentration is our x value. So we're going to plug in that 280 for x and see what we get out for our average global temperature and see how it corresponds to that 57.99 degrees Fahrenheit. Okay. Whoa, sorry. Okay, so if we plug that in, we're finding f of 280. So we're going to have 0.016 times 280 plus 51.844. So go ahead and multiply. If we multiply that, we get 4.48 plus the 51.844. So that gives us a temperature of 56.324 degrees Fahrenheit. Okay, so how well does the function from our previous part model this prediction? And we can say that it underestimates by, and let's subtract, so 57.99 minus the 56.324 by 1.666 degrees Fahrenheit. Okay, and we found that by taking the 57.99 minus 56.324. Okay, if you have any questions, make sure you email me. Your homework is posted on my math lab.